Yes, in the last session we have discussed about this objectives, that is integrated system and so on, and then optimization. So optimization is nothing but a smart grid shall optimize the assets and reduce the cost and then operate effectively. And the green energy. The smart grid shall solve the problems of following distribution systems and so on. And this is a basic diagram for a smart grid. Right? See here how the smart grids are. Say in a basic electrical grid, it is nothing but the things which are in the bottoms will be available. That is, bulk generation will be there, transmission, distribution, and then it is fed to the consumers. In addition, in a case of smart grid, the above the topmost things, the things which are in the tops are added. See here, with the generating stations, with the bulk generation is there, and then second one is the transmission is there in the bottom, and then distribution is there, and then consumers or customers. So they are monitored with the help of the markets, which is in the top, and then operations, and then the service provider. So these three things are added in a smart grid for a better way of transmission, distribution, and then the economy cost wise to attain the economic cost. See here, the solid lines are the secure communication flow, and the dotted lines are electrical flow, and the things, the dark blue things are domains. So these domains are monitored with the help of the secure communication flows. So this is the smart grid. That is, how can we transmit, distribute, and purchase or sell the power in a smart way. So this is a conceptual model of a reference diagram of a smart grid. So these things are explained in the below table. You can see that one. So these are the basic things. The domain means the actors in the domains, and then the customers, the end users of an electricity may also store and manage the use of energy. Traditionally, three customer types are discussed, each with its own domain, that is, residential, commercial, and industrial customers are there. And then regarding the markets, the operators and the participants in an electricity markets, and then service providers. The organization provides the service to an electrical customers and utilities. Next one is an operation. The manager of the moment of electricity. Bulk generation means the generator of an electricity in a bulk quantities may also store energy for a later distribution. So next one is transmission. The carrier of bulk electricity over a long distance may also store a generating electricity also. And then distribution networks. So in a case of distribution, often electricity to a and from customers, and it may also store in a general electricities. These are all the basic explanation of a diagram which are seen above. Right. So next one is challenges and the benefits of a smart grids are, first you can see the challenges. That is, first one is high power system loading. The challenges which could be faced by the smart grids are the high power system loading, increasing distance between the generation and load, and then fluctuating renewables, and then new loads, maybe hybrid or electrical vehicles, and then increased use of distributed energy resources, and then the cost pressure. Next one is utility and unbundling, and the next one is increased energy tradings, and then transparent consumption and pricing for consumers, and then significant regulatory push. This is the challenges which is faced by the smart grids, right? And then advantage of a smart grids are improved reliability, high asset utilization, and then better integration of plug-in hybrid electrical vehicles, and then reduce operating costs for utilities, and then increased efficiency and the conservation. And next one is finally lower greenhouse, that is GHG and other emissions. So these are all the advantages of a smart grids. And then the pillars of smart grids are transmission optimization, demand side management, and then distribution optimization, and then asset optimization. These are all the main pillars of the smart grids. Next one is the five key aspects of the smart grids are for the development and deployments are computational intelligence, where how the smart transmission, distribution, and the purchasing could be done with the help of the intelligent computational techniques. Next one is power system enhancement. In this, the meaning of this one is how the power system faults could be identified and rectified in a better manner, which could be done with the help of the smart grids, with the help of the fax device or some sort of renewable sources. And next one is the communication and standards. So this is a better communication networks could be added for a smart grid transmission distribution. And then environments and economics. And finally the test beds. Right. So next one is futures of a smart grid. So in the case of futures of smart grid, there is reliability, flexibility in topology, and then efficiency, and then platform for advanced services. Right. So next to some of the challenges faced presently by the Indian electricity systems are shortage of power, power thefts, poor access to electricity in rural areas, and huge losses in electric grids, insufficient power consumptions, and the poor reliability. So these are the challenges faced to nowadays. And next, self-healing. So smart grid automatically detects and responds to the routine problems and quickly recovers if they occurs, minimizing the downtime as well as the financial losses. So this could be done with the help of the self-healing technology in a smart grids. And the self-healing conceptual importance of energy infrastructures are a secure sensing communication, automatic control, and energy override infrastructure as an integrator in configurations and electronically controlled systems that will offer flexibility and the functionality which improves the system availability, security, quality, and resilience, and then robustness. So this is the basic diagram of a self-healing technologies. That is wind, solar, thermal, and HMIs are fed to the self-healing grids. The self-healing grid, these are all the functions could be carried out. That is fault circuit indicators, transformer monitors, voltage regulators, reclosures, distribution automation, and then power factor corrections, and the communication networks and software analysis, that is analytics. This could be carried out by the self-healing grids or incorporated in the self-healing grid networks. And then the smart meters, which is a bidirectional, which is fed to the smart meters, and then it is fed to the appliances, that is the consumers. So this is a basic block diagram for a self-healing technology which is incorporated for a smart grids. So the smart grid automatically detects and responds to the routine problems and quickly recovers if they occur, which is minimizing the downtime and financial losses. The main objectives of the smart grid is to reduce the downtime as well as the financial losses with the help of this self-healing technology. And The self-healing grid is a system comprised of sensor, automatic control, advanced softwares, utilities, real-time distribution status to detect and isolate the faults. So one of the main goal of a self-healing grid is to improve the system reliability. This can be accomplished by reconfiguring the switches and reclosures installed on the distribution feeder to quickly isolate the faulted session and the feeders, re-establish the service to as many customers as possible from an alternate sources. Right. So next one is requirement of self-healing grids. These things you can see that the requirements are system topology representation, pre-fault system faults, and the fault detections. Alright. So remaining things we can discuss in next session.